Yeah. So in this session, we are going to discuss about how we can design the electronic system design by using the microcontrollers. Okay. So here you can see. So see, is any electronic system? It is an orderly and purposefully arrangement of all the components, sensors, and your processing unit, along with that some output devices, which are we can call actuator. So all these things we can constitute like an electronic system. So these electronic systems we can use in any power supply systems and or any embedded microcontroller system, telecom system, wireless systems, and even medical related electronic system also we can use like this kind of design. These are the steps that we can use to design any kind of electronic system. Basically, this in this electronic system, we can differentiate in like analog and digital systems. That based on your signal, whatever the signal that you are using to capture or to monitor or to control any kind of signals. So here basically two types we have, analog and digital. Okay. So the first one is you can see source. So whatever the source means your either speech signal or any kind of signal that we are going to communicate or if you want to transmit. So that is a kind of information signal. So that we call a source. Okay. And transmitter, which is used to transmit the signal which is captured in the source block. Okay. And this transmitter will transmit the information from the transmitter port to the a channel. That channel may be a wireless or wired. Okay. So here in this channel block, may we can say some noise also it can include. So generally in wireless, you can see a lot of noise may add into your channel so that it will be disturbed or it will corrupt your whatever the source that you are going to transmit. Okay. Even if it is wired also, we can see due to some electrical variations and any other disturbance or EM radiations that these things also it can interfere your channel so that it will corrupt your information signals. Okay. So from the channel, the information, the transmitted information is received by the receiver part. So that receiver part will grab the whatever the transmitter signal is there, no, that it will receive and it will do some kind of it will extract your message signal from your transmitter signal, and that extractor message signal will go to a destination. So this is a way we will do in any kind of communication system or in any kind of electronic system also we will follow the same way. Okay. So this is a kind of analog, whereas if you are going for digital, no. So here a small difference you can find over here. So see in the center part, so you're having source the same way, whatever you're having in the analog, that is same as your analog system. Then after that, what we are doing, source encoder. So we are encoding your source. Basically, it is an analog signal, right? So that we have to change it to your corresponding a digital signal. So doing that digital part, we have to encode. So it in this step we have so many steps. We have sampling, quantization. So all these things we will do in the source encoder. After that, channel encoder. So whatever the channel that you are using in this sender part, that according to that channel we have to encode your the transmitted data. Okay. After that, you have to do anyway a modulator. So a modulate means it will modulate your information signal along with your some carrier signal. So in order to transmit a more distance or in order to protect your information signal. Okay. So further we have so many modulation techniques also which are available. After that we having transmitter antenna. So whatever the modulated signal is there, no, so that signal we will apply to the transmitter antenna. So from that it will transmit either wired or wireless. Okay, so the channel may be a wired or wireless. In the same way, we in the receiver part we have some receiver antenna, so that will captures the transmitted signal. Okay, then it will do detector or demodulator. Okay, it will extract the information signal or your message signal, and it will remove the carrier part, so which is used to send that data from long distance, or which is either a wireless or wired. So after that we'll do channel decoder. So previously in the sender part we did encoding, right? So after that, here in the receiver part, we have to do decoder part. Then in the same way, the reverse process source decoder, and finally we will get the destination, the signal or information that you transmitted from the sender part. So basically, these are the two basic block diagrams of the both analog and digital systems. Okay. Then we will go ahead with the basically in this electronic system here in this in our course, no, we are using basically all microcontroller different kind of things, and we have so many microcontroller systems are available right now. Those may be 8-bit, 16, 32, 64, whatever. So based on your application requirement, you have to select what kind of how much processing that you need for your application. So according to that, you have to select from these are different kind of microcontrollers. It may be 8-bit, the basic 8051 microcontroller, and the next one is ARM based ARM based microcontroller or microprocessors, and Arduino, that is a very user friendly. Nowadays, anyone can do on this Arduino platform. We can design a lot of electronic system embedded applications we can deploy on that platform. And the next one is Raspberry Pi. This is another in the same way the Arduino is there. No, in the same way, this is one of the platform mainly used for many IoT experiments that we can use. This kind of platform, it is having a ARM based codecs M3 or M4 microcontroller. It is having, and it is having all kind of interfaces along with your HDMI, audio, video, okay, USB, Ethernet, Wi-Fi, Bluetooth, almost all protocol switches which are embedded on this board. Okay, so these are the different kind of platforms. So according to your application requirements, maybe based on the cost or processing speed or any kind of IOs input output. So according to that, you have to choose one of this a platform for to design your electronic system. And we have a lot of applications out there in nowadays for we can build by using these microcontroller systems. Applications include robotics, home security, mobile communication, biomedical, and industry processing. All these very few applications, but we have a lot of applications are there to include these electronic system into these applications. Okay. Next, it's in a small example. Okay, it's a small example of a microcontroller based home security system. Okay, so coming to the sensors, we can use a lot of sensors which are available in the right market. So we have a PIR sensor to detect any anomaly or any kind of person will enter into that area. Smoke sensor to will detect the smoke, and glass break sensor. Camera to can we can capture the images. Vibration sensor, and kind of output means siren alarms or any kind of graphical user interfaces. Everything that we can design by using this microcontroller based system. So for home security as well as all industrial, any medical devices, all these in these applications we can integrate these microcontroller based systems, and which are very economical and we can easily deploy. So at these, okay. And door sensor we have, if anyone open the door automatically, it will give you one signal so that you can alert. Okay. So all these kind of the sensors that we can include in this microcontroller, and easily we can integrate, so that it is very user friendly, and we can easily build all kind of sensors to this microcontroller. And in the quick setup we can build these for different applications, so we can integrate these microcontroller based systems. Okay, and this is one of the basic block diagram of a microcontroller based communication system. And here we can see in the middle portion, we can see that microcontroller, it is an 8-bit PIC microcontroller. It is a one kind of, the same as your 8051, this is also one of the kind of 8-bit PIC microcontroller. You can see in the left side all kind of inputs and outputs also are there in the right side. So coming to in the left side, we have using some GPS receiver. So basically this GPS receiver is used to locate your finding your location. So of this unit, whatever the unit that you are your device, the position wherever you can go, that receiver, the GPS receiver, it will locate you where you exactly, okay, residing all around the globe. Okay, it will give you some latitude, longitude, the values which will be received from the satellite. Okay, so after doing some calculation we can find the where the exactly position of this device or your unit. Okay, and GSM modem, that is also we can use for what? So mainly we know 1G, 2G, 3G, all kind of communication, mobile communication. So in the same way, this GSM is a 2G kind of technology that we already used. And with this GSM modem is nothing but it's like a one mobile phone, so that you can receive the any kind of message or calls, anything. And also you can receive as well as you can send any kind of message, either call or any kind of message. Even internet also we can connect by using this GSM GPRS modem. Okay, and this modem is it is connected to some kind of antenna, and then it normally it will connect your mobile communication system, so that you can communicate or you can control this unit, the CPU and everything, this embedded unit that you can control by giving kind of some text message or any kind of calls. So that according to that message you have to write the code in your 8-bit microcontroller, either in embedded C or assemble. So that based on your requirement, so you have to code that. According to that code it will receive or it will act. Okay, for example, if you give some message on, then that message is received by the GSM modem. From this modem it will goes to your microcontroller. In the microcontroller you will write some code. According to that it will react, or if the coming message is on means you can on some kind of motor or any LED, so that you can actuate or you can display some information which is received by your GPS receiver, that position. Okay, where you exactly reside. So that information you can display on your output device, like LCD display or graphical display. Okay, and also you can include some kind of user keyboard keypad, so with that you can enter the numbers easily, right? So this is a one way of it's a basic block diagram of building one microcontroller based system. Okay, so in this slide, for designing any electronic system, what are the skills that you need? Okay, for a good design engineer. So you should have analytical skills so that you can analyze. So how you can build the system. So according to your the customer requirements, and then out of box thinking means, so whatever the specs will come from your customer, so on top of that you have to think about out of box. So how we can extend to some extra features or any kind of external interface. Okay, further in the future that you have to think before designing an electronic system. And the next one is circuit design and development skills. So these include so we can include the all kind of even the cost optimization also we should have that kind of skill, so that optimally we can select the devices, okay, either microcontroller or sensors output device. So according to your spec requirement, you have to optimize your cost. And thermal engineering, maybe your microcontroller produce some kind of heat or any other input IO device will produce heat. So how we can manage, so how we can reduce those things, the temperature, how we can control. The last one is packaging. So how we can pack all these kind of sensors, whether input or output device, your microcontroller along with some kind of interfaces, okay, RS-232 or SPI, I2C or USB Ethernet, how we can pack all these things in a single board, so that it will reduce your cost or it will reduce your circuit design and thermal, how we can provide the protection for this. So all these things we should have some skills to design any electronic kind of electronic systems, okay. So this is one of your this is one of the basic flowchart of your designing of any electronic system. So first you study the problem, the first box you can find, then define the design object. So what are the objectives that you have to get from this your problem, and then finding a block diagram of the solution. So to solve the above objectives and the problem, you have to design one block diagram. Means it consists of maybe a microcontroller, what are the inputs should be there, what kind of interfaces will be there, so how many IOs that you can connect externally, okay, all these things you have to draw a block diagram for to find a solution of your problem. Then select the circuit topology, what kind of topology of circuit that you have to use to get your solution. Then you have to select the components, okay, all resistor, transistor, capacitors, input sensors, output devices, everything that you have to get the list of components that you are using in your system. Then after that you have to predict the performance, so whether the outputs which are getting from your system that are meeting your problem or customer specification. If it is not, again you have to go back to that, compare with the specs, okay. So whether my given specs the given specs given by the your customer that are meeting or not. If it is not meeting, again you have to redraw your block diagram, or you have to change your objective, so that again you have to change your whole serially, you have to change according to that your specs, okay. Then after finally modeling and simulation, you have to do anyway simulation. You can use any simulator or any circuit simulator that you can use to model, or you can simulate the output. So get the cost estimate. After that, finally you have to go for testing whether the given or the developed board which is getting the proper outputs and are meeting with your constraints and the customer specification. If it is not, again you have to go back, you have to compare with your specs again, you have to do all these steps, okay. This is a way we do basic designing of any electronic system, okay. Here we can use all these kind of equipments that to design any microcontroller based electronic system. SMPS, switch mode power supply to give the power to your board, and amplifiers, which is amplifies the signal which is given from your either speech signal or any sensor signal that we can amplify. Function generator, these are used to generate any kind of sine wave or square wave or pulse. So all the signal that we can generate by using a function generator, op amps that we can use for amplification purpose, and PLL, phase lock loops and frequency synthesizers. Okay, and this sensor, we have so many sensor which are available environmental or or ultrasonic, temperature, pressure, all kind of sensor that we can use, and opto isolators that to isolate your design from the high current. Okay, that where we can use the opto isolator, and it works on some optic principles. And then outputs, if you want to control any output, we have to use some relays. Okay, and some displays that we can use LCD or graphics display. Then we can add some RAM or data store, any SD card that we can insert into your electronic system, so that you can store all kind of the sensor information and the data, which is whenever you log in, all kind of information that we can store. And the RAM data generator, we can generate a different kind of data. So, and also we can have ADC and DAC, analog to digital or digital to analog converters. So for that we can use these source encoder, channel encoding. We have to use these coders, delta coder, PCM coder, okay, pulse code modulation. So all these things that we can use during the design of any microcontroller based electronic system. Okay. So next we will go ahead with one more. Uh, we can see one a difference between uh, two technologies, that is TTL and CMOS. Okay, so here we can see, yes, yeah, I think you are able to see this. So this is the two design technologies to manufacture any kind of ICs. So these are the two kind of technologies, TTL and CMOS. TTL meant for transistor logic, and CMOS meant for complementary metal oxide semiconductor. These are the technologies that we use for fabricating any kind of ICs, integrated circuits. So here I am giving some basic differences between these two technologies. So the basic gate that we use for these two kind of technologies, for TTL it is a NAND, and CMOS for a basic gate is inverter. And the circuit is we will use transistor here. Complementary metal oxide semiconductor means we have to use two MOS transistor. First one is NMOS and other one is PMOS. So with these two MOS transistor, we can design inverter or all kind of other gates also we can build. And the speed of operation compared to CMOS TTL is more, and whereas your propagation delay per gate is, whereas TTL it is very fast, you can see 4 to 12 nanosecond only, but whereas your CMOS no 15 nanosecond it is taking for transmit the information from input to output of your gate. And the nominal supply voltage is TTL only constantly 5 volts, but whereas in CMOS no we can vary that based on your technology. So it can be vary from 3 to 15 volts. Okay. And wide collector capability, so TTL is having a passive pull-up, whereas CMOS is having tri-state output. And coming to a fan out, so how many devices in the output you can control? So that's what a fan out. How many devices that it can drive? For CMOS, it can drive up to 50, okay, whereas TTL it is only 10, okay. And noise immunity, for CMOS it is more. So the no immunity to the noise it is very good for CMOS, whereas TTL it is good. And compatibility with the other families or other technologies. So TTL you can easily integrate with the DTL, but CMOS no, there is no compatibility, but only you can compatible with the TTL only for 5 volt supply. Okay, and these are the available functions for TTL only very high. CMOS, so these are the basic differences between these two technologies. So these two technologies that we can use to design any kind of IC integrated circuits. Okay, and this is the end of session. Okay, thank you.